Whey protein is essential for building muscles, and so every day millions of people around the world consume it as part of their diet. It's derived from cow milk as a byproduct during the cheese-making process. A typical factory produces about 10,000 bottles of whey protein per day, and it undergoes several important steps from the dairy farms to the factory floor before assuming its final form as a high-quality protein powder. But what are these steps, and more importantly, how is whey protein made? The history of whey is closely intertwined with that of cheese, since they both come from milk. It's entirely possible that early humans discovered whey protein by complete accident. You see, back in the olden days, farmers used to store milk in containers made from animal stomachs. Rennet, an enzyme found in the stomach of herbivorous animals that would cause the milk to coagulate, separating into curds and whey. However, whey wouldn't become popular until much later since its health benefits remained largely unknown. The process begins with the collection of milk from dairy farms, where the cows are raised specifically for milk production. Farmers make sure that their cows are healthy and properly fed, since the conditions in which the cows are raised affect their milk production. These cows are milked 2 times a day and can produce anywhere from 25 to 35 liters of milk a day. Robotic systems are used to milk the cows to make the milking process more efficient. The collected milk is transported to the processing facility. This may involve bulk tanker trucks that are specially designed to maintain the temperature and quality of the milk during transportation. Upon arrival at the processing facility, the milk undergoes quality testing. This includes checks for temperature, acidity, and the presence of any contaminants. Milk that meets quality standards is accepted for further processing. Next up is pasteurization, a very crucial step in ensuring the safety of the milk and its products. There are 2 main methods of pasteurization. In high-temperature, short-time pasteurization, the milk is heated to a high temperature, usually around 161 Fahrenheit or 72 degrees Celsius, for a short duration, 15 seconds, followed by rapid cooling. In ultra-high temperature pasteurization, the milk is rapidly heated to a much higher temperature, usually around 280 Fahrenheit to 138 degrees Celsius, for a very short time, 2 to 5 seconds. UHT-treated milk can be stored for longer periods without refrigeration. After pasteurization, the milk is rapidly cooled to a temperature of 4 degrees. This is done to stop the milk from cooking, which could adversely affect its quality. It also inhibits microbial activity. The first step in the actual whey protein production is curdling the milk. This is typically achieved through the addition of rennet, an enzyme complex containing chymosin. Rennet helps coagulate the milk proteins, separating them into solid curds and liquid whey. The process takes place in huge industrial vats. Mechanical stirrers and agitators ensure uniform mixing of the milk and the added rennet. The coagulated milk is then separated into solid curds and liquid whey. The curds are used to make cheese, while the liquid whey contains water, lactose, minerals, and proteins. The separated whey undergoes pasteurization again to eliminate any remaining bacteria or microorganisms. This helps ensure the safety and quality of the final whey protein product. Now it's time to concentrate and isolate the protein in whey. The 2 main methods to achieve this are the membrane filtration and ion exchange technology. Membrane filtration is a cold temperature separation process that uses porous membranes. Due to their different pore sizes, membranes are capable of eliminating bacteria, defatting the whey, allowing the pass-through of carbohydrates and minerals, and retaining whey production. Ion exchange is a process that selectively isolates specific protein components. The raw whey is sent through a column that collects the proteins and separates them based on differences in their net charge. The rest, lactose and minerals, is washed away and further processed into a different ingredient. Ion exchange allows the selection of all functional and nutritional proteins in whey, including bioactive proteins such as immunoglobulins and lactoferrin. The resulting whey protein therefore has less fat and lactose, and also allows complete solubility with a clean and neutral taste. Before membrane filtration and ion exchange processes were developed, whey protein powders were insoluble, had a yellowish-brown color, and had poor taste. It was only after these processes were invented that whey protein acquired the taste and appearance we are familiar with. The concentrated whey is then subjected to drying processes to remove the remaining moisture and transform it into a powder form. In spray drying, the concentrated liquid whey is first fed into a chamber where it is atomized, meaning it is broken down into small droplets. This is typically achieved by spraying the liquid through a nozzle. The droplets are then introduced into a drying chamber. Hot air is simultaneously blown into the chamber, causing the water content in the droplets to evaporate rapidly. As the water evaporates, the remaining whey solids form tiny dry particles. These particles fall to the bottom of the chamber, and the dried powder is collected. The size of the powder particles can be controlled by adjusting the parameters of the spray drying process. The dried whey protein is then transferred to a mixing facility where it is first weighed, along with other flavorings and sweeteners which are added to enhance the taste and nutritional profile. Some whey proteins are also fortified with vitamins and minerals. The materials are then mixed in large rotating drums to ensure a consistent product that tastes the same throughout. For the packaging, an operator introduces the empty cans to a conveyor belt to start the filling process. An automatic filling machine is used to fill each can with a precise amount of protein powder. This filling machine is actually connected to an intermediate bulk container or an IBC that stores the final blend of the protein powder. After filling, each container undergoes a weight check to ensure that packaging has been done correctly. After the filling has been completed, a labeling machine labels each container with important information such as the name of the product, nutritional information, and instructions for use. A worker then inserts a plastic ring on the top of each container, which is then heat-sealed to ensure an airtight and precise closure. The containers are then stored in large totes ready for distribution. Before the containers are sent off around the globe, a team of experts tests each batch to make sure the quality standards are being met. These experts conduct a taste test and compare it to the gold standard. This ensures that the taste, texture, and consistency are correct. If not, the batch is put on hold and sent back to blending so nothing will be wasted. Today, the goal of major whey and performance nutrition companies is to offer better nutrition products to help achieve better health and level of nutrition. Whey protein can now be found in infant nutrition formulas to supplements for the elderly. If you're curious about how other products are made, be sure to check out our other videos.